All right, my friends, I hope so. I'm audible. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Yes, yes. Right. Right, my friends. So yesterday's class, what exactly we have seen in yesterday's class somewhere, we started with this concept called as climate, correct? So somewhere we understood, basically we understood what exactly is a climate. Somewhere I said climate is nothing but what? An atmospheric condition. Correct? You call it as climate, you call it as weather, there is no much difference. But technically, we said yes, there is a difference between weather and climate. So, whatever which changes, say for example, changes on an hourly basis, day to day basis, right? You call them as a weather. Am I right? Weather in the sense, see, today it can be a dry weather, tomorrow it can be a wet weather, my friend. Okay. So whatever changes with the changing time, you call them as what? Weather. Correct. And all this changing weather, if I'm just taking one average value, I call them as what? Climate. So that's the reason I always say atmospheric condition in a short run, you call them as weather. In a long run, you call them as what? Climate. So by examples, we understood what is climate. Somewhere I said that climate is nothing but what? An atmospheric condition. But what condition? Only two aspect, two property of an air mass. What is the property? Number one, right, we describe the temperature of this air mass, and number two, we describe the humidity content, my friend. Okay, only that. Temperature and humidity content, right, we describe them, correct? So somewhere, right, we have differentiated between climate and weather, and somewhere we started, right, having an idea about the forward linkages of this chapter, climatology or climate. What is climate? What exactly results in climate? Somewhere I said climate is an atmospheric condition. Temperature and moisture of atmosphere, which is determined, I call them as what? Climate. So what results in moisture or what brings the moisture to a particular place? I know it is wind. So somewhere in climatology chapter, I'm just going to talk about wind. Now comes another question. Why exactly I have this wind? What is a wind? Air mass moving from one place to another. The transit of an air mass, you call them as what? Wind. Horizontal movement of an air mass, you call them as what? Wind. Right? So wind always moves from high pressure to low pressure. That's the reason we said, right? Wind moves because of what? Pressure difference, my friend. And why there is a pressure difference? Pressure difference is there because what? Temperature difference, right? And why exactly there is a temperature difference? Because I understand, see, source of temperature is sun, insolation. But somewhere I understand the distribution of insolation itself is not uniform, correct? That's the reason we have difference in temperature, correct? Right, my friend. So somewhere I said, in climatology as a chapter, what exactly we'll be discussing? We'll be discussing about these aspects one by one, my friend. Okay, so we'll be starting with temperature, we'll be starting with okay, pressure, wind, and so on. We'll be discussing about. Okay, right, my friend. So with that, yesterday's class I said everything is fine, but climatology itself is a study of atmosphere. Climate itself is nothing but what? An atmospheric condition. So first and foremost, I should know what is atmosphere, how this atmosphere came into existence. Has this atmosphere meant for an evolution? Correct? Today, what is the composition of atmosphere and what is the structure of atmosphere? The properties of the different layers. If all these informations, if at all, if I know, understanding climatology becomes very easy. That's the reason yesterday's class we started with, right, defining what is atmosphere, and we also talked about, in brief, very short, we talked about origin and evolution of atmosphere. Then we understood today, as of today, what exactly this atmosphere consists of. What is the composition of atmosphere we talked about, right? Slightly we went beyond, right? The four major gases, and I told you, right, apart from neon, helium, krypton, and xenon, if at all, if you want to remember, right, remember hydrogen. Examination point of view, I said, always try to have hydrogen at last. Okay, so it's very easy to remember. Okay, right, my friends, right. Now, after understanding this composition, and we also said, right, which are the gases which is stable, which are the gases which is unstable, and more than being stable and unstable, we talked about this gases being active and inactive. See, we are not worried about the inactive constituents, right? We are more bothered about what active constituent. In that case, carbon dioxide and ozone, we said they are active but stable. But when I talk about water vapor and aerosol, they are active and unstable. Unstable means they will be vary from place to place. Okay, right, my friends. With that, we also discussed about the structure of atmosphere. Accordingly, what we have done, the entire atmosphere till the 10,000 kilometers of extension, we have divided these layers into 5 concentric spheres. You understand what is concentric spheres, right? Right. One is all sides surrounded by another sphere. All right. Or another layer, you call them as what? Concentric spheres. Okay. Right, my friend. So somewhere understanding says, right? Somewhere we have divided them into 5 different layers. The lowest layer, the most important layer. All right. You call them as what? Troposphere. All right. See, generally, they say if you want to remember the order, my friend, means I think very pretty. See, very easily you can remember the order, my friend. See, for example, if you can remember, right, the lowest layer is troposphere. Okay, if you can remember lowest layer, means normally they say, right, they call them as what? Trust me in the exam. Somewhere, let me tell you, if you want to remember this order, my friend, right? Okay. Somewhere I'll post means I'll just save it. Okay. When all these files through your cursor, I'll be sending it. So in examination time, you can make use of it. Last minute revision, you can always use the slides, my friend. Okay. So just for your convenience, if you want to remember these layers, my friend, just for your convenience, let me copy paste this image here, right? Normally you call them as what? Trust me in the exam. So if you want to remember the layers in order, you can remember it, right? Troposphere, stratosphere, mesosphere, thermosphere, and exosphere. But it is not that much needed. I'll tell you why. Because any middle layer is mesosphere. Only thing is that I have to remember troposphere, my friend. And outer layer, of course, you're going to call it as what? Exosphere, my friend. Right? The confusion or clarification is between stratosphere and thermosphere. So somewhere you should remember that stratosphere is also called as ozonosphere. So if you remember that, okay, ozone is present in stratosphere at the height of 30 kilometers. Am I right? So very easily stratosphere also you can remember. So not needed, but still if you insist, I'm just giving it. Okay. Right, my friend. So what are the different layers we have in atmosphere? We know. And yesterday's class, what we have done, we have taken the lowest layer called as troposphere, right? And we have discussed in detail. We said that this is the weather layer of the Earth. So whenever we are going to study about climatology, predominantly we are going to study about this layer only. Okay. And we said by size it's the smallest layer, but when it comes to the composition, this is the largest layer. That's the reason we said by mass, this is the largest layer. By volume, it is the smallest layer. Given both the fact, my friend, this is the densest layer, my friend. And somewhere I told majority of atmosphere is confined to troposphere. Am I right? Right, my friend. So with that, right, we also discussed on a very important property and we justified why this troposphere do not have uniform height. Few places I have extended height, few places I have what? Truncated height, my friend. Okay. So why exactly tropospheric height is a maximum at the places like, say for example, when I talk about equator, because I understand throughout the year, right, what you experience in this region is what? A rising convection, my friend. Throughout the year, what you experience is what? A rising convection. And polar region, throughout the year, what you experiencing is what? Experience is what? Subsiding convection, my friend. Okay. So that's the reason why exactly you have this different height of what? Tropopause. Okay. Right, my friend. So the average height also I have told you, and very important property I said, normal lapse rate is the most important property. What is this normal lapse rate? With increasing height, temperature generally decreases. But I also justified what is the reason for it. Because, see, Insolation or solar energy is the source of atmospheric temperature. There is no denial. But if you ask me, right, how exactly this atmosphere is being heated up, right? This insolation do not heats up this atmosphere directly. Insolation or sun's rays heats up the surface of the earth, and the heat that is liberated from the surface in the name of terrestrial radiation heats up the atmosphere. This is where the role of carbon dioxide and other greenhouse gases comes in. And yesterday you had one very good question, right? Why is that insolation is not heating up this atmosphere, or only terrestrial radiation is heating up the atmosphere? Two ways I should read it. Number one, I should say insolation majorly do not heat up the atmosphere. This is the perfect statement. Okay. Only ozone absorbs insolation. Other components in atmosphere do not absorb insolation. Okay. Right. Now comes the question: why only terrestrial radiation is absorbed by carbon dioxide? Why not insolation is absorbed? Because the wavelength itself changes, my friend. Insolation comes in ultraviolet, short wave radiation. Am I right? For short wave radiation, carbon dioxide or greenhouse gases is a transparent medium. Whereas for terrestrial radiation, it is an opaque medium. Okay, so wavelength changes. Terrestrial radiation, the wavelength becomes what? Infrared in radiation. Right, my friends? Okay, so this is where we have ended the last class. So today what we have to do? We have to discuss about the rest of the layers. Okay, so after troposphere, today what we have, the layer to be discussed today, right? We'll start with stratosphere, my friend. Some of the facts here is very, very important. Right. So we have a layer called a stratosphere. My dear friends, the stratosphere as a layer, often it is called as ozonosphere, my friend. Also known as ozonosphere. Right? You call them as what? Ozonosphere. Also known as ozonosphere. Okay. Why? Because this is the layer where the ozone as a layer is present, my friend. Okay. See, this is stratosphere. And I know that fact that stratosphere, if you ask me where exactly stratosphere as a layer extends, stratosphere as a layer extends right between this tropopause and the stratopause, my friend. Right? It extends between tropopause and stratopause. Right. It extends between tropopause and stratopause. Okay. You know the height. Tropopause, the height is not uniform. Right? A few places 8 kilometers, few places 18 kilometers. All those stuffs you know. Correct. And stratosphere, if you ask me, stratopause, right? It extends up to the height of what? 50 kilometers. And my dear friends, this is the layer where you have the what? Presence of ozone. Okay. So approximately where, if you ask me, ozone is present right between 20 kilometers and 35 kilometers. Approximately, see, books to books, this value will change. Never mind. But where exactly ozone is present? Stratosphere. That's it. Am I friend? This is the layer where you have this concentrated ozone, my friend. Okay. What you have is what? Concentrated ozone. Okay. Okay. Now, my dear friends, if you ask me, what is the property of this stratosphere? Right? What is the property, if you ask me? Right? You know that this is the place where you have this ozone. See, ozone can sometimes also be written as O3, my friend. Okay. Sometimes O3. It's a form of oxygen. Ozone is a form of oxygen. Okay. Right, my friend. So this is a layer where ozone is present. Now, my dear friends, what is the property of this stratosphere, if you ask me? You increase the height. You increase the height. With increasing height, the temperature also increases, my friend. Temperature also increases. I am writing it as temp, you write it as what? Temperature. And if you ask me why, see, for example, normal lapse rate, With increasing height, temperature decreases, but here it is vice versa, right? This is all because of what? Presence of ozone, my friend. Presence of ozone. If ozone would have not been there, presence of ozone. Okay. Because I understand ozone, the direct source or the primary source itself is what? Sun, my friend. What happens, say, for example, when I talk about this ozone as a layer, right? Say, for example, I'm just talking about this ozone as a layer, my friend. Okay. Let this be ozone as a layer, right? Right. Now, when I talk about this sun's rays which is surpassing this ozone, my friend, right? Okay. Assume that this is ozone as a layer, my friend, right? Now, say for example, assume, right, sun's rays is penetrating this ozone. See, ozone, ozone is a UV filter, my friend. Most of the time, right, you call ozone as a UV filter, right? What is UV filter? UV filter means what? Ultraviolet radiation filter. It means what? Ozone is an insolation filter, my friend. Okay. Ozone absorbs insolation. Okay. Ozone absorbs insolation. How? Say, for example, assume if 100 percentage of insolation is entering atmosphere, okay, what percentage of insolation comes to troposphere is only 86 percentage, my friend. If that is the case, what happens? Right? Ozone, my friend, ozone absorbs what percentage? It absorbs 14 percentage of insolation. Very important, right? That's the reason ozone is a filter. Okay, so simple, my friend. So ozone is primarily heated by what? Sun. Am I right? If it is being primarily heated by sun, it is something like water in the oceans, right? Right. Say for example, water, the sunlight is penetrating the multiple layers. So generally, you tell me, my friend, you know it, right? If I'm just taking the layer of water, which layer of water will be more warmer? Upper layers of water will be more warmer. Lower layers will be comparatively colder. The same principle you apply it. Okay. So as the case I understand, you increase the height, temperature decreases. Am I right? So upper reaches you will be having more temperature, right? Lower reaches you will be having less temperature. Okay. So why ozone? We have an idea. And one more thing, when I talk about stratosphere and the temperature increase and decrease, this increase in temperature is applicable only when ozone as a layer starts. Okay. Till then, temperature doesn't mean, for example, right, there is no change in temperature. Like finally in consolidation we will see. Okay. So my dear friends, let me tell you, ozone absorbs insolation. Correct. Ozone is a UV filter. Am I right? UV filter means what? Ultraviolet UV is nothing but what? Insolation. Right? Right. So it filters insolation. Right, my friend. So everything we have an idea. Now, my dear friends, yesterday's class I told you, right? Normal lapse rate is the one, right, which predominantly results in what? Cloud formation. Am I right? Here you do not experience normal lapse rate. What is normal lapse rate? With increasing height, temperature should decrease. That is normal lapse rate. Right. If that is the case, here you do not experience normal lapse rate. Right, my friend. So if that is the case, my friend, can I conclude that stratosphere will be relatively free from clouds, my friend? It is relatively free from clouds. I'm not saying completely free from clouds. It's relatively free from clouds. Right. Now, if that is the case, understanding says, my friend, see, when I talk about flight, my friend, flight normally avoids the layer where you have clouds because normally when I talk about, okay, first we'll write it. Right. So simply I said it is relatively free from clouds. Okay. Now, my dear friends, when I talk about flights, you know that flights generally prefer a layer where the cloud is very less because flights avoid what? Turbulence. Okay. Flights avoid what? Turbulence. Right. See, that's the reason most preferred layer for aviation industry. This is stratosphere, my friend. Most of the aircrafts are confined to what? Stratosphere. Okay. Now you should not ask me what about landing and takeoff? Will it come to troposphere? Of course it should come. Correct? Right, my friend. Now let me give you a very small question, my friend. Okay. You answer it. What all you can find it in, okay, what all you can see in stratosphere, my friend? What all you can see in stratosphere? Let me give you an option. Okay. A. Flights. B. Weather balloon. C. Some birds. 18 kilometers of height. Some birds. D. All of the above. What all you can find in stratosphere, my friend? So this is a simple question, expecting some answers from you, right? What all you can find it in stratosphere? I'm just giving you some of the choice. Flights. Flights means aeroplane, weather balloon, some birds, or all of the above, my friend. Give it a try. D, 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 and D. Chale, okay. Now here comes some of the questions, my friend. Okay. See, flights, yes. We do find flight because just now I said there's the most preferred layer for aviation industry. Flights, yes, of course we have. Right. Now we are not very sure about weather balloon. Okay, of course, weather balloons are confined to what? Right. Stratosphere. But comes the question, birds. Do birds fly that high? That's the question. But my dear friends, here I have a word of rescue. Okay. See, this is a question which is already asked in the examination. That's the reason I'm also bringing it. All right. See, somewhere you have the qualitative word which makes life simple, my friend. Okay. Of course, well said. The answer is all of the above. But why I have chose the bird, I'll tell you. Because number one, I know flight, I know weather balloon. Am I right? If both are there, the best option should be all of the above. But only thing is that I'm just confirming with the birds. Right. Now I talk about birds, my friend. What exactly is the word which is making me to go for birds? Is this word called as some? Am I right? So some birds. Okay. So when I talk about some birds, yes. With all these some birds, flights, weather balloons, right? With all of the above, right? I can go with what? All of the above. Right, my dear. See, of course, there are birds which were confined to what? Stratosphere. Okay. Particularly when I talk about the migrating birds, my friend. Right. And of course, see, everywhere the height of the tropopause, right, is not 18 kilometers. Am I right? If you're there in the polar region, temperate region, it is right, complete, slightly it is less, right? It comes at the height of what 10 kilometers and so on. So the best option here is what? All of the above, my friend. Okay, very good. Now, almost all facts about right stratosphere we have done it. Okay, right, my friends. Now coming to the third layer, my friend. Not much, right? The third layer of our right discussion. It's a mesosphere. You call them as what? Mesosphere. So I talk about mesosphere, my friend. Right. I talk about mesosphere. It's a middle layer, right? Any middle layer, you call them as what? Mesosphere. See, in Earth's interior also, you have one mesosphere. Lithosphere, asthenosphere, mesosphere, outer liquid core, inner solid core. There also you have one mesosphere. Correct? Crust, mantle, and core is one way of classification. Lithosphere, asthenosphere, and so on is another way of classification. Am I right? Okay. So just want to tell you, any middle layer you call them as what? Mesosphere, my friend. Mesosphere is very similar to that of what? Very similar to that of troposphere, my friend. Very similar in character, right? Similar to that of troposphere. Similar to troposphere. Why I say it is similar to troposphere? Because in troposphere you increase the height, temperature decreases, my friend, right? So here also you increase the height, temperature decreases, right? And my dear friends, if you have this phenomena with increasing height, the temperature decreases, right? What you're going to have is what? The formation of clouds, right? Mesosphere also you will be having cloud, and this cloud is very popularly called as noctilucent cloud, my friend. This cloud is called as what? Noctilucent cloud. Right, noctilucent cloud. Okay, these are mesospheric cloud. Correct. But these clouds, right, name itself says noctilucent, my friend. I'll tell you how exactly this cloud looks like. So I talk about this noctilucent cloud. Right, they are the cloud which is confined to water. Right, see the height. Somewhere around 85 kilometers, my friend. 76 to 85 kilometers they are located. Okay, very highly placed cloud in the sky. Okay, somewhere around 50 to 80 kilometers of height, these clouds are located. Okay, now my dear friends, these clouds will never result in precipitation. Okay, even if this cloud is resulting in precipitation, this cloud will not reach the surface of the earth because given the distance, my friend. Okay, so just want to tell you that you do have these clouds confined to what? Mesosphere. But climatologically, it has a very less role, my friend. Okay, so mesosphere also you have a cloud. That's it. Okay, now coming to the fourth layer, my friend. Right, this fourth layer you call them as what? Ionosphere. Right, you call them as what? Ionosphere. See, there I have written it as thermosphere, but I'm not worried. Right, let me discuss about ionosphere. So I talk about ionosphere, my friend. Name itself says, right? Ionosphere is an electrically charged layer. Electrically charged layer, my friend. Okay. And my dear friends, that's the reason. Name itself says what? Electrically charged layer. And this layer, say for example, this is the layer which facilitates communication, my friend. Somewhere you can take it also. It's an electrically charged layer, right? And it facilitates communication. It facilitates communication. And this layer, somewhere I can write, and it facilitates communication. Particularly radio communication, my friend. Okay. So this is an electrically charged layer, but this layer, as I told you, that it means facilitate what? Radio communication, right? Normally we say, right, for radio communication, line of sight is not needed. All right. So normally when I talk about not so high frequency, when I talk about the low frequency waves, right, it will not allow these radio waves to almost surpass this ionosphere. It will get reflected back to Earth's surface. All right. Okay. Everything is fine. But let us be confining our discussion only to geography, right? If that is the case, my dear friends, like this layer, right? Somewhere I understand one geographical phenomena takes place, my friend. Somewhere I told you, right? This is an electrically charged layer. So what happens? Whenever an electrically charged spectrum or electrically charged particles of the sun is emitted, am I right? Assume that it is emitted, right? Right. Yes. Right. So whenever this charged particle of the sun is entering the Earth's atmosphere, I have a layer which is also electrically charged. So what happens? Both these electrically charged particles, that is the particles of ionosphere and the particle which is emitted from sun, my friend, if both goes for a collision, this collision will result in a very beautiful light-like phenomena, my friend. Very popularly, that phenomena, you call them as what? Auroras. We call them as what? Auroras, my friend. Aurora, right? Aurora, see, sometimes auroras looks like an exaggeration, but my dear friends, aurora, sometimes you call them as what? Aurora Borealis and Aurora Australis, right? It's one of the most beautiful phenomena, like a light, like a laser light show, what you experience in the sky, my friend, right? That's what you call them as what? Aurora, right? Borealis, or you call them as what? Aurora Australis, whatever it is, right? Somewhere. See, these are exaggerated images, but still, approximately this is how this auroras looks like, my friend. Right. Right. This is how this auroras looks like, my friend. Okay. And sometimes when I talk about aurora, we call them as what? Polar lights. We call them as what? Polar lights, my friend. Why auroras is called as polar lights, if you ask me? Right. Auroras confined, or auroras as a phenomena, happens only in the polar region. Okay. Now, my dear friends, right. Maybe I'll just represent this Aurora Borealis. How exactly this Aurora Borealis happens? See, somewhere, if I'm just explaining the process, what I understand here, my friend, see, when the solar wind, layman's understanding, solar wind, am I right? Otherwise, you can call them as what? Electrically charged particle from the sun. If the electrically charged particle from the sun is emitted, am I right? It gets, say, for example, we have a magnetic shield around the earth, right? It gets deflected, but I tell you, my friend, but the electrically charged particles get attracted, right? They get attracted towards the polar region, my friend. Am I right? So that's the reason whenever this electrically charged particles, they collide with the ionosphere, right? They result in a light-like phenomena. You call them as what? Auroras. My question, number one, why exactly, right? This solar wind or electrically charged particles, when it reaches Earth's atmosphere, what is the reason or why exactly it is, say for example, deflected towards the polar regions, my friend? Why it happens only in the polar region? Any reason, my friend? Why aurora as a phenomena happens only in the polar region? Right. In between there was a question, sir, in which layer does lightning and thunder occurs? Lightning and thunder occurs in troposphere, right? And that too in troposphere, only the cloud which is located, right, somewhere below this 2.5 kilometers of height. 2.5 kilometers. Only there lightning and thunder occurs. We have a type of cloud called as cumulonimbus cloud. Yes, Mr. Emmanuel, we have cumulonimbus cloud. Thunder is a result of this cumulonimbus cloud. Okay, right. Now coming to this aurora. Okay, I asked a question. Very good. Pankaj Raj, very good. So due to Earth's magnetic field which deflects the charged particles towards the poles. Right. Very good, my friend. And if you ask me what is the reason, right, even Sneha has given me the answer. Fantastic. Why aurora happens in the polar region? Because polar regions are the place where the magnetic field of Earth is very, very strong. Am I right? Even the deflecting solar wind gets attracted towards what? Polar region. Right? Because today, where exactly you have this north and south magnetic pole? Any idea, my friend? Today, where you have this north magnetic pole, which country at least? Any idea? Which country you have this north magnetic pole? No, see, north magnetic pole is there near North Pole itself, right? It's in Canada, my friend. Very good. It's in Canada. There is an island called as Queen Elizabeth Island, or largely this island is called as Baffin's Island, right, in Canada. North Pole is different. See, normally people say that North Magnetic Pole will be there in Southern Hemisphere and South Magnetic Pole will be there in Northern Hemisphere. Accepted, no denial. But by convention, today, what is there in North Polar region, you call them as what? North Magnetic Pole. What is there in Antarctic region, you call them as what? South Magnetic Pole. This is by convention. Okay. Right, my friends. So, North and South Magnetic Pole, where it is located. At least North Magnetic Pole, today it is located in Canada. Very good. It's located in Canada, my friend. Okay, right. Fine. So, only thing is that, what is Aurora? I said, a fantastic, beautiful light-like phenomena. You call them as what? Aurora, my friend. See, and this Aurora itself, right? We have two types of auroras, my friend. What are the two types of auroras, if you ask me? Auroras happens in both the hemisphere, right? Auroras of the northern hemisphere, my friend. Aurora of northern hemisphere, we call them as what? Aurora Borealis. I'll just simply write it as NH. NH means northern hemisphere, you call them as what? Aurora Borealis. What is this Borealis, if you ask me, right? See, actually you are seeing a forest here, right? The name of this forest, you call them as what? Boreal forest or taiga forest. Okay. So this Aurora Borealis is named after this forest. Okay. If you're there in southern hemisphere, my friend, if you're there in southern hemisphere, right? You call them as what? Aurora Australis. You call them as what? Aurora Australis, my friend. Because somewhere you can find this phenomena, right, from the southern regions of Australia, my friend. There is an island called as Tasmania. So there you can find this aurora as a phenomena taking place. Okay. So auroras of the north, what is the name? Auroras of the south, what is the name? Both we have an idea. Okay. So this is all about ionosphere, my friend. Right. And finally, right, yes, ionosphere. And when I talk about exosphere, my friend, right, see here, I am differentiating this ionosphere and thermosphere. Okay. Now what I am taking, finally I am just taking this thermosphere and exosphere both. Right. So simple, only one fact I would like to bring in, right? Both this ionosphere and thermosphere. Thermosphere, both, my friend. You increase the height. What happens to the temperature? Temperature also increases. Somewhere you can write it, my friend. Thermosphere is the warmest layer in entire atmosphere. Right? Somewhere I can write it. Thermosphere. Thermosphere is the hottest layer, or I can call it as what? Warmest layer. Warmest layer in entire atmosphere. Entire atmosphere. See, the temperature and thermosphere extends beyond imagination sometimes. You will not even imagine will this atmosphere will get heated up this much now. Till 111 degrees or 1100 degrees centigrade, this thermosphere has experienced its temperature, my friend. Okay. So that's the reason I said you increase the height, temperature also increases. Okay. Now, somewhere, when I talk about beyond mesosphere, my friend, what I have is thermosphere. Okay. Now comes the question: thermosphere and exosphere both are very warm, my friend. See, you would have heard about this International Space Station, right? When I talk about International Space Station, the height of International Space Station At what height this International Space Station is placed, if you ask me, it is at 408 kilometer, my friend. Okay. Talk about International Space Station. Right? I'm just talking about the height of this International Space Station. It is somewhere placed at 408 kilometer from the surface of the earth. But this height keeps on changing, am I right? Every day, every time it will not be 408. You have this perigee and apogee positions that keeps on changing. Okay, whatever it is the case. Right, 408 kilometers, my friend. So somewhere I understand it is placed at the junction of this thermosphere and exosphere. Am I right? So somewhere at the upper limit of thermosphere, let me take it for practical cases. Okay. Temperature is very, very high according to the data what I have. Am I right? Now, my dear friends, now imagine, okay, that you are an astronaut, my friend. Imagine that you are an astronaut. Okay. You are there in International Space Station. Okay. You are there in International Space Station. You just want to check that how exactly the temperature outside looks like. Okay. So what you're doing now is very simple, right? You just want to experience that. Okay. So somewhere you're putting your hand outside and checking that what exactly is the temperature outside, my friend. Now you tell me, if you're putting your hand outside, what exactly you'll be feeling, my friend? You're an astronaut. You're placed in an International Space Station. Itself is almost there in thermosphere at the higher level, right? Somebody said temperature is going to be very high. You just put your hand outside and just you're going to check the temperature outside, my friend. How hot the temperature will be. What you will feel? Don't tell me that I feel excited. Okay. What you will feel, my friend? About 4000 Kelvin. So minus 273 will give my centigrade. Okay. 4000 Kelvin. Anything else, man? Any other choice? My dear friends, you will not feel anything. Neither it will be cold nor it will be warm. Correct. Why I'll tell you, my friend? Because only if you have a medium outside. If you have any medium outside, my friend, this medium will be absorbing this insolation and it will be very hot. Correct. If you do not have any medium, am I right? See, somewhere I understand the density of this air mass is very, very less, very, very thin, my friend. So as the case, you will not have any medium as such. If you do not have any medium, my friend, you will not feel any heat. But if you're putting your hand outside and checking that how hot this temperature will go, right, slowly, steadily, what happens? Your hand will start absorbing this insolation. Right. If you're putting your hand outside, right, to check the temperature, let me tell you, my friend, that will be the last time you'll be seeing your hand because it becomes so hot. Okay. Right. So somewhere I understand, right? The place where I have International Space Station, the temperature is very, very hot. And that's the reason. Normally, we have a mechanism where this structure will be tilted. Every time it will be tilted by an angle. Why? Because they ensure that one side of the satellite or one side of the station should not become superheated. Okay, that's the logic, right? Right, my friends. Almost every fact about all the layers we have taken it. Thermosphere and exosphere, the primary source of temperature, both this layer, my friend, the primary source of temperature is insolation itself, right? Primary or direct source of temperature, if you ask me, what is the primary or direct source of temperature? It is insolation itself. That's the reason. As you move towards the sun, the temperature increases. Okay, right. Right, my friends, almost all the facts we have taken it. And finally, before concluding it, right, a very simple but still a very useful diagram. So last minute revision, this will be very useful, my friend. So all the layers, if I'm just taking it, just looking for a better image. Information in this image is fantastic, but only thing is that okay, better. Right. So now a complete atmosphere if I'm just taking it. Complete atmosphere if I'm just taking it. Right. Now with increasing height, temperature decreases and increases with various layers, my friend. Say for example, if you're there in troposphere, somewhere you can find it, the temperature decreases. Correct? If you're there in stratosphere, you find that temperature increases, my friend. Somewhere you can find it, right? Right. So somewhere, if you're there in, see, this is one side height and one side temperature, my friend. In troposphere, temperature decreases. Again, I said till it reaches stratosphere, temperature neither increases nor decreases. But as it reaches the ozone as a layer, right? What happens? Right. Temperature increases, my friend. Again, in mesosphere, temperature decreases, thermosphere, it increases. Correct? So every alternate layer, the temperature decreases and increases. So one layer you remember, right? All the layers automatically you can remember, right? This is number one. Okay. Now, my dear friends, here, what is that I should understand? I'll tell you what, right? Now, entire, say for example, the question is in entire atmosphere. Okay, I am asking you, my friend. See, any picture, it's a source of information. If that is the case, you tell me. Right, take the clue from this graph. You have to tell me in entire atmosphere where exactly the minimum most temperature is recorded. Taking the clue approximately from this diagram. Entire atmosphere where the minimum most temperature is recorded. Lower part of thermosphere. Okay, fine. Slightly adjust. This picture is not so correct. So somewhere you can take it as what? A mesopause level. What you tried to say is very good, right? But just to tell you, my friend, the lowest temperature is recorded at what? Mesopause level, my friend, right? Somewhere you can take it. Am I right? Very important fact, my friend. Entire atmosphere, the lowest temperature is recorded. Lowest temperature in atmosphere is recorded at mesopause level, right? So what is this mesopause level, right? What is this mesopause level, my friend? Okay. So upper layer of this mesosphere, you call them as what? Mesopause level. Okay. Right. So the temperature is somewhere around minus 100 degrees centigrade approximately. This is one very important fact. Not even in, right, this tropospheric level or tropopause level, it is at mesopause level, my friend. Okay, right. Fine. So this is all about atmosphere in all sense. All sense we have completed atmosphere. Okay. Now after completing atmosphere, now what we'll do? We'll take the case of what? Right, insolation. First we'll talk about insolation. Then we'll be talking about temperature and so on we'll be going. All right. Right. So with your permission, I'll just take some 3 or 4 minutes break and be coming back, my friend.